There we go. I had YouTube playing as I was recording. Sorry. All right, so we're going to get started. Like I said, we're honored to have Caitlin and Greg from Loyola speaking on their projects that they did. So before we get started, I'd like to thank our sponsors and then do a brief introduction about some of our next topics. So Variant Technologies has been a sponsor with us for several years now. They do defense contracting. They're always looking for folks that are interested in software engineering, system engineering, data science. If you're interested in learning more about them, you can reach out to me. Clarity Business Solution is another defense contracting company. They're a little smaller, but they're also doing some interesting work in system and software engineering, big data analytics, data science. If you're interested in talking to them, please reach out to me. ICF is a much larger company. They're around 7,000 folks, and they do more than just defense contracting. They also do some commercial work all over the place in Rockville, Columbia. I think they're also doing work down in Virginia. If you're interested in learning about them, you can reach out to me. Aries Ventures is my company. We're very small. We do software engineering, system engineering, and data science, and that one's easy. If you're interested, just reach out to me. And then Loyola, I'm very happy that Loyola's helped us with this. Loyola has their data science program in both the graduate and undergraduate. If you're interested in learning more, you can go to their website. But both Caitlin and Greg are from there, and they do a lot of outreach to the community. They do a lot of outreach to industry, so I think they're a good program. So if you're interested in learning more, you can look at the website or contact me. And then coming up next month, we have a meetup on how to automate Splunk deployments using Terraform and Kubernetes and Docker and Splunk. So it's very interesting. I've seen the presentation. It's actually going to be a demo. This is going to show how to use Amazon Web Services and spin up things. And then in August, we have one of the speakers from O'Reilly talking about building machine learning applications. And with that, I'm going to hand it over to Greg and Caitlin. So Greg got into data and programming while studying astronomy. I've seen his presentation on Comic Book. It's really interesting. I think you'll get a lot of insights into how they're pricing and some cool things. And then Caitlin's going to talk about predicting outcomes with animal shelters. So I've also seen their work. So if you have any questions, the way that I'm going to handle it is if you can type your question in Zoom or YouTube. I'm going to look at both. I'm going to grab the questions and then I'll ask them at the end. So with that, I'm going to hand it over to Greg. So I'm going to stop sharing, Greg, and it's all you. Unmute yourself and share your screen.
All right. Everyone see that all right? Okay. So, yeah, my name's Greg Muir. I am one of the master's data science students at Loyola. And yeah, I'm going to be graduating. I got one last class, so wrapping things up here in the next couple of weeks, and looking for opportunities in the data science world. So if you know anyone who's hiring, please don't hesitate to reach out. And my capstone project here, I'm going to go over this in kind of broad strokes, and I'm not going to go too much into the code. If you'd like to take a look at that, I've got a GitHub repository set up here that does have some of the code and examples and stuff. So if you'd like to take a look at that, the link is here on the first page. So my capstone project was on predicting the profitability of out-of-print comic books and graphic novels. So when I was 13, my older brother, he bought me a copy of Wolverine Volume 1, and he told me to keep it in good condition because it was going to be worth thousands of dollars one day. So I very diligently read it once, put it back in its little plastic case, and then stashed it in the closet and forgot about it for 20 years. So I looked recently at the price on it, and much to my dismay, it's selling for about 99 cents. So it just goes to show that not all comics appreciate in value. And it's really hard to predict which ones will. So we'll talk a little bit more about that in this presentation here. So the client for this project was mybargaincomics.com. So they are an online retailer of out-of-print comic books and graphic novels. And the way that the sort of the comic industry works, You have major distributors, which get the comics from these suppliers, from the publishers, and they sell them to comic book shops at wholesale prices. And so while comics are available from the distributors, they're considered in print, and they tend to have pretty flat prices. So if you walk into your local comic book shop, sort of wherever it is, this week's Superman is going to be $3 or $4, right? You aren't going to see huge price fluctuations on that. Now what happens is when comics are no longer available from the distributors, then they're considered out of print. And the only way to get them is through the secondary market. So that's other comic book shops. That's people selling on Amazon or eBay. And that's where you have this fixed supply. And so if there's a lot of demand for a comic, you can see big swings in the prices that it's retailing for. So that's where you'll see comic books worth thousands or millions of dollars, is when they're out of print. So the goal of my project is to build a regression model that's going to take in data that's new stock from the distributors, and it's going to predict how much those comics will sell for once they are out of print on the secondary market. And the data from this comes from Diamond Comic Distributors, which is the largest comic distributor in America, and they're located right here in Baltimore. And the goal is to take in this new inventory, right? So it's really important that the features that I'm using, that I'm building this model with, are going to match sort of what my client has for the new data. So I really need to be using kind of this this data from Diamond, but I'm trying to get it to approximate out of print comics, right? So stuff that's no longer at the distributor. And that was a little bit of a challenge. So they publish a full stock and a low stock inventory every day, but they don't archive it. So I was only able to go back as far as September, on this low stock spreadsheet. And my initial thought was, I'll look only at the low stock from as far back as I can, and that'll be a best approximation. But one of the silver linings, at least for this project, of the whole COVID-19 situation was that Diamond was one of the businesses that had to close its doors as a non-essential business. So when I generated pricing data, it was not supplying any comics to any of the comic book shops. So kind of all of this data is going to pretty closely resemble out of stock comics. So the price trend should match that, which is nice for me. And one other thing to note with that is that this is not a very good secondary market example, right? We have a ton of people, we have millions of people who are out of work. We also have people who are getting, checks from the government and spending them on comic books and things. So it's not going to be a particularly representative time period. So it's going to be important to retrain the model when things kind of normalize. So back to the data though. So they publish, that full stock and low stock spreadsheet every day, and it's got 18 features apiece, about 20,000 items in the full stock list. And the key features are the title, the supplier, genre, the year it was published. There's a flag for a low stock indicator, the height, width, and length. The other features were mostly kind of identifying features, or things without much discriminatory power. So the approach for this, one of the features that I didn't mention there was any kind of secondary market price, right? Diamond will give us the price to the wholesale price essentially, but I've got to find out a way to get a secondary market price and sort of pair those up. Then I'm going to use that secondary market price to calculate a markup. So kind of a percentage increase in cost. And I'm going to use that as my target feature for regression. I'm going to engineer some features. I'm going to perform a training test split, train and tune some models, and then I'm going to pick the model with the highest R-squared score. So for those of you guys not all that familiar with R-squared scores, it's a kind of a measure of how much of the variability of a regression model or of a data set is captured in the regression model. So the higher the R-squared square, the better. An R-squared score of 1 would mean that all of your data points kind of fall right on your regression line, whereas an R-squared score of 0 is going to be basically random. So I'll choose the model that has the best R-squared score and use that on the test set to make predictions and identify the most profitable comics. So the tool that I used for finding these secondary market prices was the ISBN database. So they have an API where you can put in a string for the title of a book, a comic book, whatever, and it's going to return sort of the 40 closest matches that it has. And it's also going to return a little bit of extra information there. And 3 of those things match up with what I have access to in the Diamond inventory. So that's the title, the supplier, and the year it was published. So I'm going to use those 3 things to make sure I've got a good match. And when I've got that, it'll give me an ISBN 13 number, which I can then use with the API to look up a secondary market price. So we're going to talk a little bit about the details of how I did that matching. And one thing to point out as well is that the title field from Diamond was really messy. I had to do a lot to clean that up. So we'll talk about kind of how that works. But ultimately, by matching on that title, supplier, and year, I was able to get matches and generate prices for 49% of the data that I had. So I mentioned that the text fields, the titles are really messy. And we can see an example of that here in the bottom left-hand corner. So Diamond tends to include some additional information along with the titles. So it's, product restock codes, it's special editions, it's, what kind of book, what kind of comic book it is. And we can see that that's just kind of jammed in here in an unstructured way in that title field. So I needed to, in order to feed these strings into the API, I needed to remove all of that extra stuff so that I'm going to get good matches, right? I don't want to confuse the API there. So the way I went about doing this is I did some word tokenization. And the way that works is you take the whole string and you just kind of split it up by white space, right? So you're going to take each individual word or group of letters or numbers or symbols, right? And treat each of those as a token. And what I did then was make a dictionary, right? So I could put counts of them, and then I sorted by the most frequent. So I did this for all, 10,000 or so matches that I had. I did this for all 20,000 of the things in the inventory, right? And I sorted by the counts of the most frequent. So we can see that TP, which stands for trade paperback, and GN for graphic novel here are occurring pretty frequently. So they were some of the highest tokens that appeared. And I consulted with my subject matter expert, so my client for this project, on which of these tokens that appeared frequently were useful, things that we would expect to be in the title of comic books or graphic novels, and which seemed to be these codes that were added in. And once I did that, I was able to develop a list of stop words, right? And that's literally just a list of the words that I want to filter out. And so what I did was I went back through title by title, broke everything up into tokens, and checked to see if each of those were on that stop word list. And if they were, I removed them. And then I put everything back together. And that's how we get from this messy kind of bottom left-hand corner to a much cleaner bottom right-hand corner here. And then we're gonna get into sort of how the title matching happened. So even with all of that, there was still some issues, right? And the issues were that I was looking at data from 2 different databases, right? We have what Diamond labels things as, and we have what the ISBN database labels things as. So for example, the titles and the suppliers, the publishers didn't always match. So one of the really big comic book publishers is called Dark Horse Comics. And so they're listed as Dark Horse Comics by Diamond, but when we look in the ISBN database, they're only listed as Dark Horse. So if I were to do a string comparison, they're not going to match because the two strings don't exactly match. But I know that those two things are the same. So what I need to do is figure out a way to get a similarity score or a measure of close but not exact. And that's the same thing for titles as well, right? Like Godzilla King of Monsters Destroys Tokyo and Godzilla Destroys Tokyo are two very different titles from a literal sense, but they're probably referencing the same thing. So I used what's called a Jacquard similarity index. And the way that works is you'll compare those two strings or the tokens that are in those two strings, and you'll take the number that are in both and you'll divide that by the number that are in either. So if we're looking at that Dark Horse Comics example, in both of those, Dark Horse and Dark Horse Comics, we share Dark Horse. So that gives us 2 tokens that are shared versus 3 tokens that aren't. So we'll get a Jacquard similarity index score of 2/3. And so I use that, and I set it up in kind of a hierarchical way, right? Where as I went through the 40 results that were returned per title, I looked to see if we had any of these matches. And you can see kind of the hierarchy that I set up here at the bottom. What I considered to be the best match is if we had a title match above 50%, a publisher match above 50%, and the year published matched exactly. And so if we had that, I took it and made the connection there, made the match there. And if it didn't, we continued through everything. And I set it up so that if we had a better match, it wouldn't be replaced, but we would kind of fill in where I found something if that better match didn't exist yet. So, and with that, I was able to get that 49% of matches. And I think that that's a pretty good balance where, you know, there might be some errors here, but I'm still getting enough data to do some good analysis with, right? If I made it really stringent, I might only get 100 results that match perfectly. So I think it's walking a, you know, there's a little give and take that goes with it. And I think I found a pretty good balance with this. So that got me secondary market prices, right? The API, the ISBN database API, it returned, you know, new and used prices from, you know, a bunch of online vendors. So mostly Amazon and Abe Books. And I assigned the secondary market price to be the lowest available one. So whether it was new or used, I just picked the lowest price. And I created this markup feature that was the secondary market price divided by the price of my client, you know, acquired it from Diamond. So that's that base Diamond price times a supplier discount. And it varied supplier by supplier. So Marvel versus DC or whatever. And it's based on, you know, the volume that he sells. So this markup, I'm gonna, you know, kind of look at it as a target variable. But first, I threw it into a histogram. And we can see kind of what the distribution of that looks like in the top right-hand corner here. So there are a couple things to note about this distribution. The first is that the vast majority of these markups fall below 1, right? And what that means is if you're purchasing a book at wholesale cost from the distributor, and then you're turning around and selling it at the lowest available price online, you're losing money more often than not, which just kind of shows the importance of sort of being able to identify which comics are profitable, because on average, they aren't. And the other thing to notice is that we've got a pretty heavy right skew on this distribution. And that's going to make it difficult to you know, have an accurate regression model with this target variable. So the way that we can fix that is we can do a log transformation. So I used a natural log transformation, and we can see in the bottom right-hand corner here that makes the it makes the log markup, it makes the distribution much more normal looking. You know, it's not perfectly normal, but it's a whole lot better than that top distribution up there. So with that target variable, I moved on to some feature engineering here. So there were a bunch of features that came in the data from Diamond that were categorical. So supplier, there were over 100 different suppliers of comics. And so I didn't want to include every single one of those as a one hot encoded feature, right? Where we take one categorical feature and we split it out into however many categories there are of 0 or 1, right? Where if something is DC Comics, it gets a 1 in the DC Comics category and everything else gets a 0. So that's a way of taking this categorical data and turning it into something that a regression model can work with. But we need to be careful about, you know, adding too many features there. So what I did was I looked at the average markup by supplier. And I split that out into low stock or not. And what I was really looking for were the suppliers where the average markup really varied from an average of 1, right? So I was looking for really high markups and I was looking for really low markups. And the other thing I was considering was how many there were of each of these. So, you know, if there were only 10 counts of something, I consider that far less important than if there were 1,000 counts of something that maybe didn't have as big a variation. So ultimately, I wound up selecting 11 features to include, 11 of these suppliers as kind of one hot encoded features in the data set. And I did the same thing here with the genre. So everything was assigned a 2-character genre code by Diamond. And we can see AD, adult comics, have a really high average markup, while SH, superhero, have a pretty low one. So from this, I chose 10 genres to include. And there were other categorical features. There's one for brand code, where you know, something might be labeled for Batman or for Superman, but that ran into multi-collinearity issues, where Batman is a superhero comic from DC, and we've already included those 2 things in the data set, so I didn't want to muddle it up there. So with those features included, I got into modeling. So I split it up into a 2/3, 1/3 split for the training set and the test set. And then for each model, I performed 10-fold cross-validation. And you know, the way that works, you take your training data and it gets split up. So you split it into 10 different partitions, and you'll train 10 different models, excluding one of them each time to use as a validation set. And that lets you tweak things. It lets you, you know, tune hyperparameters, things like that, without just kind of training for what the test set looks like. And so for I used both the full stock and the low stock data sets because I wasn't sure what was going to be more accurate. And I figured that both were viable candidates since Diamond wasn't currently shipping things for either. And I used 3 different subsets of features. So I hand selected a subset of features, sort of based on intuition and conversations with my subject matter expert. And then I used a full set of features as well, where it was basically everything where I removed obvious multicollinearity, sort of identifying features and features without much discriminatory power. And then I ran a lasso model on that full set and just looked at what features that lasso model selected and used that selection as a 3rd subset of features to train models on. And I trained 5 different types of regressors. So a ridge, lasso, support vector, random forest, and k-neighbors. And I also used a tree-based pipeline optimization tool called Teapot I learned about at a DataWorks talk, I think from January or February. But the way that it works is it kind of automates a little bit of the model selection and hyperparameter tuning, and gives you a pretty good result. Takes a real long time, but you can get some interesting information from it. And the best model wound up being a random forest regressor that was trained on the full stock data set with the hand selected features. And that wound up achieving an R-squared score of 0.258 on its tenfold cross validation. And I was really pleased with that score because essentially this is a problem of commodity price prediction, right? We don't expect the R-squared score to be incredibly high. And if we were like predicting stock prices and had an R-squared score of 0.258, you should definitely quit your day job because you'll be a billionaire, right? And what I wound up doing was I made my predictions on the test set. And then I imposed kind of a cutoff on the predictions. And we'll take a look at this on the next slide here. So we can see on the y-axis, we've got the actual markup. And on the x-axis, we have the predicted markup. And so I've color-coded everything so that the green dots are ones where the actual markup is greater than 1, which means that they're profitable. Right? If you buy that comic and then you sell it at the lowest possible price, you're making money on it. And all the red dots are comics that are unprofitable. So we can see in the top left corner here, the vast majority of the dots are red, right? And so what I did to get to this this graph on the right was I imposed a cutoff where everything that was predicted to be a negative, to be a value less than 1, to lose money, I eliminated that from the results. And so what we're left with is just things that are predicted to be profitable. And you can see we lost a lot of data, right? Like the majority of the points were excluded, but the ratio of these positive ones, of these profitable books to the non-profitable books, it goes way up, right? It looks a whole lot better. And as we look back here, we can see kind of what happens at different prediction thresholds. So with that prediction threshold of 1, where we're just, we're taking everything that's predicted to be profitable and removing everything else, what happens is the percentage of markups that are actually profitable, right? It goes from 0.249 up to 0.627. So we're more than doubling our chance of selecting a profitable comic. And the average profit per item went from a loss of $2.69 up to a profit of $3.28. And so if we take a look at this graph here, what we'll see is on the x-axis, we've got the different thresholds that we're looking at. And on the y-axis, we're looking at, the percentage of profitable items in that remaining pool. And then it's color coded for the actual average profit. So greener is better. And the size of the dots, we're looking at how many results there are. So we can see with no threshold imposed down at 0.0, we've got a lot of data points, but the average profit is not very good. And the percentage of profitability is that 0.249. And then as we set that threshold higher and higher and higher, we see that average profit going up and the percentage of positive, the percentage of profitable books going up as well. And so while it looks like, there aren't that many results when we look at, a threshold of 1.5, right? We've got to remember that this is kind of the data that we were able to find prices for. So 49% of the data. And then this is the test set. So that's only 1/3 of those. So we're probably looking at about 6 times more results when we feed in new data. So a threshold of 1.5, give my client about 90 or so books to look at with that same ballpark of profitability. And it kind of lets him tweak things to how he wants, right? if he wants to stock 1,000 different titles, then he probably wants to set that threshold a little bit lower and kind of pick and choose from those results. But if he wants to buy 1,000 copies of 5 different titles, he might set that threshold really high and have 30 results to look from, and he can kind of use his intuition there and his business sense and pick and choose those. So anyways, that's my project. Does anyone have any questions?
That was cool, Greg. So I got a couple questions. I had a couple questions, and there was a couple asked. And if anyone has any other questions, please type them in so I can gather them. So you talked about that your code's available. One of the questions was like, what tools and languages did you use, and like what did you take into consideration when you were picking the tools and languages that you used?
Yeah, so I used Python, and I did some stuff with the NLTK package for that tokenization, working with the titles, and then I used a lot of scikit-learn for the actual models, and then like I mentioned, that teapot package, that was pretty helpful as well. So I was mostly looking for things that I had some familiarity with. I've done a lot of work with Python sort of in my coursework here, and with those packages in particular.
Okay. What about the data size or data set size? Someone was asking like how large it was.
So it was about 20,000 rows, and 18 features from there.
Okay. So Matt had a question, and I'm gonna actually understand this question, but he said, why would you need both a 2/3 to 1/3 test train split and a T-fold CV?
So you want to have different, you want to be able to tweak the models, right? And so that's what you use that evaluation set for. So I looked at a bunch of different parameters, how many things I was looking at in the random forests, right? Like how many different trees, or how I wanted those splits to be. And I wanted to make sure that I wasn't sort of biasing the results, right? Like I didn't want to make my split, a training test split, right? And then tweak things on the training set until they looked really good on the test set. Because at that point, you're just kind of choosing the model that works best on the test set. And it's not necessarily going to generalize really well. Like if you had a different test set, it might not work all that well, right? And so what I was looking for was, to use that cross-validation technique so that I could play around with the different hyperparameters of the models, try a bunch of different models, and see what tended to work best as a whole on that training set, and then use that to make one prediction on the test set and use those as my results, right? So I wasn't rechecking things against the same test set. I found the best model based on that cross-validation, then made one prediction on the test set to use as results.
He asked a quick follow-up. He just said, was the 1/3 test set really more of a validation set?
Well, so the cross-validation is kind of where the validation happens, right? And then the results that I'm getting are going to be out of that test set.
Okay. So I had a couple questions. So I'm not as familiar with comic books, and I thought it was interesting when you showed the chart that showed certain brands were a little lower, certain genres, and you mentioned like the adult actually was higher, which was kind of interesting. I mean, did it match what did you have any theories going in, and did it match it? Like I just don't know many of the brands.
Yeah, I had some theories going in, and it didn't. I expected, like you hear about the comic books that sell for the highest amount of money, right? Like Action Comics #1, the first appearance of Superman. I expected superhero comics to sort of be one of the bigger driving forces there, right? Some of the other things that I thought would, and it turned out that they weren't, right? Some of the other things that I thought might move the price a lot were, I also created a feature for just a flag for if in the title it said volume 1 of something. I flagged that because I figured on the secondary market, right? Like there are very few people who are going to be purchasing volume 7 of something that haven't purchased volume 1. That more people would look at that first one, decide if they wanted to continue reading it, and there'd be more demand for the earlier volumes. And that turned out not to be the case. I don't know, maybe they just print a whole lot more of volume 1 than of the later volumes. But that was something that I was expecting to do that. You know, I took a look at the one of the nice things about, are you guys still seeing the PowerPoint, or did we flip over to
we see the PowerPoint.
okay, let me stop sharing, and I've got some feature importance here. All right, can we see this? So this was one of the things that you know, with a random forest model, you can kind of look at the feature importances. So the most important feature wound up being the volume of the comic book. So literally the height times width times length of a comic book, which just goes to show that probably the larger special edition books, or the sort of the big omnibuses, where you've got a lot of comics together, tend to be, you know, so some of the more profitable ones. You know, the year it was published, whether it was a superhero comic or not, Dark Horse, Marvel, DC, those were some of the bigger ones there. You know, adult wound up being not as important as I thought it was. So it was interesting to see.
Cool. All right, great job, Greg. So with that, I'm gonna stop the questions right now and hand it over to Caitlin, and then at the very end, if there's anything, we can try to, you know, grab a couple more.
Sounds good.
Let's have Caitlin share her screen, and then she can take over.
Okay, can you hear me?
Yes, we can hear you.
And can you see my screen?
Yeah. Yep. Looks good. You're good.
All right. Let's see. One second. Trying to fit in the people. Okay. All right. Hello, everyone. Thanks for listening in. My name is Caitlin Longo, and for this presentation, I'll be talking about my capstone project for Loyola University Maryland's Data Science Masters. And my project was an analysis of Frederick County animal control data. Oops. Just a little bit about myself. I'm a lead data scientist at Booz Allen Hamilton, and I've been there since 2016. I have a bachelor's in mathematics from UMBC and just completed my master's in data science from Loyola University, Maryland. Just wanted to give some background about my client, which is Frederick County Animal Control. Their mission is to prevent animal cruelty and abuse and neglect, to shelter animals that don't have homes and to help them find their forever homes. And lastly, to educate the public on animal issues to create a more aware community. They've done a little bit with their data, but they were definitely excited to get a more in-depth analysis from my project. So first, I'd like you to meet Scooby. Scooby is a senior dog that was sadly surrendered by his previous owner. He was at the Frederick County shelter for about 39 days, but thankfully he was adopted. Unfortunately, not every dog or cat that enters a shelter will end up finding their forever home for a variety of different reasons. So for my project, I decided to use data analytics to look into why some animals get adopted and some do not. I broke up my project into two different parts, which was a descriptive analysis portion and then a predictive analysis portion. So for the descriptive portion, I looked at things like peak intake months. I looked at different areas where the most dogs and cats were coming from in Frederick County. I looked at popular adoption times. And lastly, I looked at trends in how long dogs and cats wait to be adopted. The predictive portion was the biggest part of my project, and I used machine learning to try and predict a dog or cat's shelter outcome. And when I say shelter outcome, I'm talking about things like, was it adopted? Was it returned to its owner? Was it euthanized, etc.? And then lastly, I used those machine learning models to try and figure out the top determinants for predicting that outcome. And then wherever I could, I tried to come up with some sort of actionable insight for the Frederick County shelter based on the results of my analysis. The tools I used were pretty common. I used Tableau for all of the data visualization, and I'm going to walk you through a little dashboard that I created for my client. For all of the coding, I used Python and Jupyter Notebooks, and then the main Python packages I used were scikit-learn and XGBoost. So getting into the data, I had data from October 2011 through September 2019, and it came to me in two different parts. The first was an animal intake part and then an animal outcome part, and examples of these data sets are shown on the right of this slide. There were roughly 34,000 unique animals, with the majority being dogs and cats, and I focused on dogs and cats for my analysis. Some examples of the fields in the data were the species, primary and secondary breed, color, age group, gender, name, intake type. So that's like, was it a stray animal or was it a surrender, etc. And then outcome type. So getting into the data pre-processing, first I had to join the two data sets, the intakes and the outcomes, and I was able to do that by joining on intake date and animal ID. Next, I did a little bit of data cleaning. So this was actually not too bad. Luckily, the data was pretty clean. Just had to remove some irrelevant columns that I didn't need and just cleaned a few columns to make sure they were consistent across the board. And lastly, I did some feature engineering. So I created some new features like date time features. I calculated how long the animals spent in the shelter. And I also did a little bit of online research to get the overall energy level and shedding level based on the primary breed of that animal. So next we'll get into the descriptive analysis. The plot here is showing total intakes per month broken out by intake type. So as you can see, intakes are at their peak in the summer months, particularly June and also in October. And this is driven by both surrenders and strays. And it actually turns out that people surrender their animal on purpose in the summer to avoid pet sitting and kennel feeds, which is pretty sad. So a potential recommendation for FCAC is to maybe lower or even waive their adoption fees during these months of high intake to try and encourage adoptions and make room for more animals coming in. So next, I analyzed where most of the dogs and cats were coming from, and I created some heat maps shown on the right of this slide. So unsurprisingly, most of the dogs and cats were coming from zip codes that directly surrounded the Frederick County shelter. So that makes a lot of sense. I was also able to find that Thurmont, which is 21788, was a huge problem for cats. This is a very rural area in Frederick with a lot of farmland. And it turns out that this is the top zip code for the number of seized cats and also the second top zip code for the number of stray cats. So potential recommendation is for FCAC to maybe focus on Thurmont to implement more spay and neuter programs, or even try to work with some vets in the area to try and reduce their costs to help control the number of cats coming from Thurmont. Next, I analyzed the adoption times. So I created another heat map. On the x-axis, we have hour of day, and then on the y-axis, we have day of week. So as you can see, Wednesday evenings and also Saturday afternoons are when most of the adoptions are happening. FCAC can use this information to figure out when they should schedule their adoptions, or even when to figure out when they should schedule other events so they don't interfere with their adoption times. They also might see that Wednesdays are super popular, so they might decide to extend their hours on Wednesdays to make more time for adoptions. So last in this section, I analyzed how long dogs and cats wait to be adopted based on the age of the dog and cat. So the box and whisker plots here on the right show the distribution of how long dogs and cats wait to be adopted, broken out by 3 different age groups. So I have adult, so that's 1 to 4 years, juvenile, and then senior. I did a hypothesis test to see if there was a relationship between the age and how long they wait, and it was statistically significant. So this shows that there is some sort of relationship between the age of the animal and how long they actually wait to be adopted. You can also see that juvenile dogs typically are adopted the fastest, which is kind of makes a lot of sense. And also adult aged cats, so that's 1 to 4 years, waited a median of 91 days to be adopted, and that was actually the longest. So a potential recommendation is to focus on promoting adult age cats on social media more often, or even place them in the front of the shelter to hopefully encourage speedier adoptions for these cats. All right, so next I just wanted to quickly show a Tableau dashboard that I created. Can you guys see this? Yes, okay. So this was just a way for me to put all of my visualizations.
Hey, Kaylin, it's showing your
Oh, you can't see it?
it's showing the slide. It looks like it's showing the slide still, yeah.
Okay, hold on 1 second. Can you see it now?
Yes.
Okay, so this was just a way for me to put all my visualizations in one spot and to kind of incorporate a interactive component. So just wanted to quickly scroll through this. For example, they can filter to a specific animal, so they can filter to cat or dog or other. And also in this case, they can filter to a specific year if they wanted to do that. Scrolling down, I also incorporated some word clouds of common names in the data set. So if you hover over it, you can see the count of that name in the data set. Scrolling through some more, I created this sand key diagram, which is super cool. Actually not very easy to make, but I found really good YouTube tutorials for this. So I can filter to, say, dogs, and basically we can see, if I hover over juvenile, you can see that most of the juvenile dogs are actually getting adopted. So that's pretty cool. And yeah, that's about it for that. Let me go back to the slides. Can you see the slides now?
Yes.
Okay. All right, so now I'll move on to the predictive analysis. So my goal was to be able to predict a dog or cat's shelter outcome, and I decided to create a binary target variable, which was euthanasia as one class and adoption/return to owner as the second class. I decided to remove all of the other outcomes in the data set because there weren't enough observations in those categories. And I also created separate models for dogs and cats. The algorithms that I chose for this were random forest, XGBoost, which is very common in Kaggle competitions, and logistic regression with lasso regularization. And I chose these algorithms because they provide more insight into the important features that make those predictions. And then on the right, you can see the breakout of the 2 data sets, the dog and cat data sets. You can see that they're not very large, and also they're a little bit imbalanced. So that's just something to note. So quickly wanted to go through some pros and cons for the different algorithms that I chose. Random forest is very straightforward. It works really well out of the box. This is definitely my go-to algorithm when I have a classification problem. It also provides that feature importance, which I really like. And the only con I could really find was that sometimes takes a while to make predictions. I've never actually run into that issue, but I guess depending on the size of your data set. Yeah, so XGBoost is, like I said, is very common in Kaggle competitions. It usually results in really strong performance. Also provides that feature importance. However, it's not as easy to interpret and there's a lot more hyperparameters to tune, so that can be a little cumbersome. And then lastly, the logistic regression with lasso regularization is super easy to implement. There's no parameter tuning. Also lets you remove some of the non-important features. However, a con is that if the features are correlated, it kind of chooses the ones that it includes randomly, which could be potentially problematic. So my approach was first to split the data into test and train. So I did a 60-40 split for the cat data set and a 70-30 split for the dog data set. Next, I trained the data. So I did k-fold cross-validation using grid search on the different hyperparameters to find the optimal set of parameters. And then lastly, I assessed the models on the test set based on accuracy, F1 score, and area under the curve. And then I looked at the top features. So next I wanted to give a little more background on the different performance metrics. So first is accuracy. This one's definitely the most common. However, this is not something you should be using when there's imbalanced classes. So for my data, I definitely took this metric with a grain of salt. F1 score, I use this one the most. It keeps the balance between precision and recall, and it's really good for imbalanced data. So this is the one I typically focus on. And then I also looked at area under the ROC curve. So this basically tells us how well the model ranks positive versus negative samples. You should also be a little bit wary of this one when you have imbalanced data. All right, so moving right on into the results. The graph on the left shows the results for cats and on the right for dogs. So basically you can see that across the board, the different algorithms pretty much perform the same. The F1 score is pretty much around 0.75 for both dogs and cats. So the metrics are pretty close to 1, but definitely shows some room for improvement. So I digged a little bit deeper by looking at the precision and recall metrics for the dog and cat models. So first, starting with cats, you'll notice that recall was pretty low for the adoption/return to owner class. So this essentially means that the model misclassifies cats that have a higher chance of being adopted or returned more often than the opposite case. Now moving on to dogs, recall was actually lower for the euthanasia class. This means that the model misclassifies dogs that have a higher chance of being euthanized more often than the opposite. I think this is a little bit more problematic because I think the ultimate goal of a model like this would be to see if animals are at high risk of being euthanized. So we really want the model to do a good job with predicting the euthanasia class. So next we'll talk about the top predictive features. So I used the feature importance plot from the random forest here. So first, this is for the cat model. Essentially the important features were the age of the cat, the condition the cat was in. So that's like, was the cat sick or was it normal? And then the intake type. So again, that's like, was it a stray or was it a surrender? Now, on the other hand, for dogs, the top features were fairly similar that they were for cats, just in a little bit of a different order. So most important features were the intake type, again, the condition of the dog and the age of the dog. So I think things like condition makes a lot of sense because typically sick dogs and cats are more likely to be euthanized. But I really think that this analysis shows that the age of the dog and cat is very closely related with its outcome. I also wanted to make a note that stray cats had a very low chance of being adopted, whereas stray dogs were almost always returned to their owner. So there's definitely a huge cat problem, especially in Frederick County. So these are just some conclusions, just wrapping up my recommendations based on the descriptive analysis. So these were to potentially lower some of their fees in the summer months in October, to focus on Thurmont for different spay and neuter programs to try and control the number of cats coming from that area. Also potentially extend their hours on Wednesdays because it was such a common time for adoptions. And then lastly, since adult cats wait the longest to be adopted, try to highlight them more often on social media. And then the machine learning portion was pretty successful, but there's definitely room for improvement. I found that the most predictive features were related to the age, the overall condition of the animal, and the intake type. But I really think that to enrich this analysis, we need more data from additional shelters, not just one shelter. And it would also be great to get more detailed behavioral data about the animal. And that is actually all I have. So let me know if you have any questions.
Good job, Caitlin. So actually, I had a question about the Wednesday. I mean, was there any theory or any reason why you thought, or why it seemed like it was happening more on Wednesday?
That's a really good question. And somebody actually asked me that in my other presentation. I have no idea why Wednesdays are popular for adoptions. I don't know if that's their choice or if that's just because everybody likes Wednesday evenings.
Yeah, I was wondering, like, because one thing I had a question for both you and Greg, but you can go first because I had some other questions. Like, when you're working with the client for these projects, are they giving you a lot of feedback? Are you working closely with them, or is it more they just give you?
So mine was actually not very engaged with me. She kind of talked with me in the beginning and said, like, this would be really nice. Go for it. So I kind of just took some of her questions and went with it. She really, really liked the data visualization aspect because I think that's like easiest for them to grasp and directly like make an impact with that. So yeah.
With the Tableau stuff, is that done completely in Tableau, or do you have to use Python or anything?
Sorry I didn't hear the first part.
I'm sorry. The question was with the Tableau. There was a question about Tableau, and you showed a lot of things there. Is that completely done in Tableau, or do you have to do other?
Yeah, for like the descriptive analysis section, everything I did was in Tableau, but when I looked at like the feature importance plot, that was using Python.
Were there other animals? I mean, did you have data for other animals? You just didn't do it, or?
I did, yeah. I had a lot of different animals, but dogs and cats are definitely like the most. So I wanted to focus on those.
Okay. All right. If anyone has any other questions, please type. I had some general questions for both you and Greg, so we can go back and forth.
Okay.
We always have a lot of interest from folks that are trying to get started in data science and like what resources. So I guess you both talk a little about your experience. Like, were you familiar with data science and had you done any self-study before the program? Did you find like the project you were working on challenging? Like, did you have any lessons learned from those projects for people that are trying to do stuff on the side? You can go first, Caitlin, and then I can.
Yeah. So I definitely didn't have a lot of experience with data science, especially machine learning. I think that if it wasn't for this program, I wouldn't have a good foundation of machine learning, especially because they require us to take a course that focuses on the actual algorithms and how they work. So I think that really helped me. And then what was the second part of your question?
Well, it was more of, do you have any lessons learned? Like, I mean, you were getting formal training, through the program, but do you have any lessons learned for folks that are trying to get started in data science? Like, were you still learning on your own, trying to find resources? Do you have any recommendations, things that helped you guys when you're going through the program?
I'm going to defer to Greg to see if he has anything.
Go ahead, Greg.
Yeah. So yeah, I was coming into the program like, the past 7 years, past 10 years, I've been working as a rowing coach, right? So I haven't been in data. I haven't been doing any programming in that aspect, right? Like I did a little in college 10 years ago, but it's been a while, right? So like Caitlin mentioned, the program's really good at getting you those kind of like fundamental skills and getting you up to speed really quickly with those. I'd never programmed in Python before, and the first class, man, it was it was 0 to 60. It was a little rough the first couple weeks, but getting up to speed, they did a really good job with that and getting me all the tools that I needed. And they also focus on the statistics of it too, so you're not just like learning how to use these packages and like hope it works, right? But when it doesn't, you have a little bit of that problem solving. You have that kind of broader knowledge to take a look at maybe why something isn't working, or to when you Google it, to be able to figure it out on your own. And I think that was one of the really important things, is that the foundation is really broad that they teach, so that everything is changing, right? Like there are new models coming out, there are new techniques. Like you can't just like learn everything that you need to know in a classroom environment and just be set, right? Like you have to have the tools to be able to continue to learn on your own. And I think the project was very much that, but a lot of the coursework that we've done has been that as well, where it's been really challenging, and you have to Google a lot of things, and you have to that you've got professors who are there to help you through it, but like it is very much that sort of discovery process on your own, where you're not just handed like the roadmap to how to get to the answer. You've got to kind of figure it out. And I would say one of the takeaways that I had from the project was that like the modeling is really the, I don't know, that's the sexy part, right? Where like, oh, look at what this model can do. But that's not kind of the key to it all. For me, it was very much figuring out the features, taking a look at the data and figuring out what to include and what not to. And that will end up being way more important than which model I used. I tried, all the same models with different features, and had an R-squared score of 0.02, and then I took a look at the data, I graphed things out, I chose different features, and the R-squared score really jumped up, right? So it's not necessarily just about what model you use, or this neural network, or whatever it is, right? Like it's about being able to take a step back, look at the data, and find sort of the right path forward for it. Because that's the kind of thing that, they've got all these tools that can automate kind of the model selection process. But, figuring out, taking a look at the data and figuring out what features you want, or taking, building new features from the ones that you have that wind up being better, is what I think is more important, or that's my takeaway from the project, at least.
Yeah, that's good. I mean, it sounds like for both of you that you learned a lot more hands-on actually doing the project than maybe from class, right? And I think it's probably a lesson that everyone probably is aware of, but it's always good to remind. It's like you learn the most when you're hands-on, you're actually getting in there and playing with the models and the programs and seeing the results of what you change, right? So I don't really have any other questions. I think you guys did a great job, and I think it was pretty awesome seeing the next generation in data sciences is how I like to pitch it. And congratulations on everything you've done, and I really appreciate it. And with that, I'm just going to say we're going to wrap up. Thank everyone for attending. If you have any questions about anything, you can reach out to me. If you have questions for the speakers, send it to me and I can put you in touch. And I hope everyone has a nice rest of their Sunday, and look forward to seeing each other next month. Thanks again, Caitlin and Greg. You guys did a great job.
Thank you.
And
Thanks.
yeah, I'll see you guys. Have a good evening.